Far beyond the warmth of the sun, four enormous worlds circle in silence. They are called the Jovian planets, and together they form the realm of giants. Jupiter, Saturn, Uranus, and Neptune. Each one is a monument of gas storms and mystery. When we look at them, we are not just looking at planets. We are seeing the engines of our solar system, the keepers of its balance, the guardians of its secrets. These planets are not like Earth. They do not have mountains or oceans or solid ground beneath your feet. Their surfaces fade into endless clouds. Their skies stretch for thousands of kilometers, and their storms last for centuries. The light that touches them is weak, but their presence is immense. They are made mostly of hydrogen and helium, the same elements that built the sun. Yet within that simplicity hides complexity beyond imagination. For centuries, humanity has looked at these worlds through tiny circles of glass, trying to understand what lies beyond the blue of our sky. Then came the spacecraft. Voyagers Galileo Cassini and Juno revealed that these giants are alive with motion and energy. They pulse with storms, magnetic fields, and auroras that would swallow our entire planet. Each of them holds a story of birth, violence, and beauty. The Jovian planets are not only the largest bodies in our system after the Sun, they are also the oldest. They remember the early chaos, when the solar system was still forming, when dust and gas spiraled together under gravity and became worlds. Studying them is like reading the opening chapter of a cosmic book that began 4.5 billion years ago. In this journey, we will explore their layers and their hidden hearts. We will learn why Jupiter glows with power, why Saturn's rings shine like frozen light, why Uranus spins sideways, and why Neptune's winds race faster than any hurricane on Earth. These are not just facts. They are clues to how our solar system was built, and how countless other systems across the galaxy might have been born. The deeper we go, the stranger the story becomes. Inside these worlds, gas turns to liquid, and liquid becomes something entirely new. Pressure rises to millions of times what we know. Temperatures climb to thousands of degrees. Hydrogen becomes metal. Lightning flashes through clouds made of ammonia and methane. Moons dance in magnetic storms. This is a world both beautiful and violent, both ancient and alive. So let the journey begin. From the familiar warmth of Earth, we travel outward to the realm of the giants, a place where sunlight fades into cold darkness and gravity rules all. The Jovian planets await, and through them we will discover not just how planets are made, but what it means to live in a universe of endless creation. Jupiter is the monarch of our solar system, the largest planet that dominates the night sky with its bright, steady glow. It is so massive that more than 1,000 Earths could fit inside it, and yet it spins faster than any other planet, completing a full rotation in less than 10 hours. Its sheer scale creates a magnetic field so vast it would appear larger than the Sun if it were visible to the human eye. Jupiter is made mostly of hydrogen and helium, the same elements that form stars, but unlike a star, it lacks the mass to ignite into nuclear fusion. Instead, it shines through reflected sunlight and the energy it releases from its own immense internal heat. When you look at images of Jupiter, you are not seeing a solid surface. You are seeing the tops of clouds swirling in endless motion. These bands of color stretch thousands of kilometers across, sculpted by powerful jet streams and monstrous storms. The most famous of all is the Great Red Spot, a colossal storm that has been raging for centuries with winds faster than any hurricane on Earth. It is so large that it could swallow our planet whole, deep beneath the visible clouds. Jupiter's atmosphere grows denser until hydrogen begins to behave like a liquid metal. Here, lightning flashes hundreds of miles long illuminate the darkness, and pressures crush anything that dares to enter. Scientists believe there may be a small rocky or metallic core at the very center, but new data from NASA's Juno mission suggests something even more mysterious. Jupiter's core might be fuzzy, a diffuse mix of rock, metal, and hydrogen blending together without a clear boundary. This strange discovery challenges everything we thought we knew about how giant planets form. Jupiter is not alone in its vast domain. It is surrounded by an entourage of at least 90 moons each, with its own story. The four largest, discovered by Galileo in 1610, are called the Galilean moons: Io Europa, Ganymede, and Callisto. Io is alive with volcanoes, erupting continuously under the pull of Jupiter's gravity. Europa hides an ocean beneath its icy crust that may harbor the conditions for life. Ganymede is the largest moon in the solar system. Even bigger than Mercury, and Callisto is a frozen, ancient world scarred by craters older than time itself. Jupiter's gravity acts like a cosmic guardian, protecting the inner planets from countless comets and asteroids that might otherwise strike Earth. It shapes the orbits of everything around it and its magnetic field traps particles in vast radiation belts that glow with auroras more powerful than any on Earth. To study Jupiter is to study the history of our solar system, a story of formation, collision, and survival written in clouds and storms. Beneath its beauty lies mystery. The deeper we explore, the more questions arise. What created its fuzzy core? What drives its colossal storms? And how long will they endure? Jupiter stands as both a protector and an enigma, a living laboratory of cosmic power, reminding us how much of the universe still waits to be understood. If Jupiter is the king of the planets, then Saturn is the jewel of the solar system. No other world shines with such grace and mystery. Saturn floats far from the sun, a golden giant wrapped in icy rings that stretch hundreds of thousands of kilometers into space, and yet remain thinner than a single kilometer in depth. These rings are made of billions of tiny fragments of ice and rock, each one catching sunlight and scattering it into a soft glow that has fascinated astronomers for centuries. Saturn is the second largest planet in our solar system, composed mainly of hydrogen and helium. Its density is so low that if there were an ocean large enough, it would float. Saturn's atmosphere is layered with clouds of ammonia and water vapor, creating soft golden bands that move gently in endless winds. Some storms on Saturn can rage for months, forming white spots that wrap around the planet before fading into silence again. Beneath these beautiful clouds lies a vast ocean of liquid hydrogen, which grows denser and hotter the deeper it goes, until it turns metallic under the crushing pressure. Like Jupiter, Saturn may also have a fuzzy core made of heavy elements mixed with hydrogen and helium instead of a single solid center. This discovery, supported by data from the Cassini mission and studies of Saturn's rings, shows that the interiors of gas giants are more complex than we ever imagined. Saturn's core seems to be slowly dissolving into the surrounding layers, blurring the line between rock, metal, and gas. But what makes Saturn truly unique are its moons. Each one is a world of its own. Titan, the largest, is shrouded in a thick orange atmosphere, richer in organic compounds than any other body in the solar system. Lakes and rivers of liquid methane and ethane flow across its surface under skies dimly lit by a distant sun. If life can exist in such alien conditions, Titan may hold the clues to forms of chemistry unknown to Earth. Then there is Enceladus, a tiny icy moon that sprays fountains of water vapor and ice into space from cracks near its south pole, hinting at an underground ocean that could harbor life. Saturn's gravity and magnetic field create an environment of constant motion, pulling on its moons and shaping the rings into intricate patterns. The planet's rotation flattens its poles and stretches its equator, giving it a graceful but powerful presence. When viewed from afar, every swirl of cloud, every icy shard in the rings tells the story of a planet that has balanced beauty and power for billions of years. Saturn is more than a planet. It is a reminder of the harmony that exists in the universe, where chaos and order dance together in perfect rhythm. Its rings are not just decoration, they are the remnants of creation, fragments of moons or comets torn apart by gravity, but transformed into something breathtaking. Saturn invites us to look deeper to see how destruction can give birth to beauty, and how even the coldest worlds can inspire wonder. Among the four Jovian planets, Uranus stands apart as the quietest, the coldest, and the most unusual. It rolls around the Sun on its side, spinning, like a ball tipped almost 90 degrees compared to every other planet in the solar system. This strange tilt makes its seasons extreme. One pole can face the Sun for more than 40 years, while the other lies in endless darkness before switching places for the next 4 decades. Uranus is an ice giant smaller than Jupiter and Saturn, but still massive enough to hold more than 60 times the volume of Earth. Its pale blue color comes from methane gas in its upper atmosphere, which absorbs red light and reflects blue. The air above Uranus is calm and featureless at first glance, but deeper inside, powerful winds sweep around the planet at hundreds of kilometers per hour. Layers of water, ammonia, and methane ice form beneath the clouds, creating a world that blurs the boundary between gas and solid. Scientists believe Uranus has a rocky core surrounded by thick icy layers and an outer shell of hydrogen and helium. Unlike Jupiter and Saturn, which generate strong magnetic fields from deep metallic hydrogen layers, Uranus produces a magnetic field that is lopsided and tilted far from its axis. The source of this magnetic field lies closer to the surface, perhaps in a shell of ionic or superionic water, where atoms move like a liquid, but carry electric charge. This gives Uranus a magnetic field that wobbles and shifts dramatically as it rotates. The planet's moons add to its mystery. Each one is a frozen world shaped by ancient impacts and hidden forces. Miranda, the most dramatic of them all, looks like a patchwork of canyons, cliffs, and craters, as if it has been torn apart and reassembled more than once. Its surface tells the story of a violent past, while moons like Ariel and Titania show smoother terrains carved by flowing ice and ancient frost. Uranus also has a faint system of rings, thin and dark, made mostly of dust and rock fragments. They orbit in harmony with the planet's gravity, forming a quiet halo around its tilted axis. When sunlight catches them at just the right angle, they shimmer faintly like ghostly ribbons across the darkness of space. The origin of Uranus's tilt remains one of the great mysteries of planetary science. Many scientists think that in the early days of the solar system, Uranus was struck by a massive object, possibly as large as Earth. The collision could have knocked it onto its side and disrupted its internal layers, giving it the strange magnetic field and the frigid, calm atmosphere we see today. Uranus reminds us that the solar system is not a place of perfection, but of beautiful chaos. Its silent blue glow hides storms and secrets deep within layers of ice and gas. It teaches us that even in the farthest corners of the Sun's reach, there are worlds that defy expectation and rewrite our understanding of what a planet can be. Uranus is a planet that defies expectations. It rolls around the Sun on its side, as if the universe decided to tilt it for a reason. Unlike any other planet in the solar system, its axis of rotation is tilted by about 98 degrees. This means its poles experience decades of continuous sunlight, followed by decades of darkness. Its pale blue-green color comes from methane gas high in its atmosphere, which absorbs red light and reflects blue. Uranus is an ice giant, composed mostly of icy materials like water, ammonia, and methane mixed with hydrogen and helium. Deep inside it may have a small rocky core, surrounded by icy mantle layers. Scientists believe something massive may have collided with Uranus long ago, causing its extreme tilt and reshaping its history. Despite its calm appearance, Uranus hides storms and winds that can reach 900 kilometers per hour. It is a frozen world drifting silently through space, holding secrets we are only beginning to uncover. Neptune is the farthest giant planet from the Sun. a deep blue world wrapped in mystery. Its color is even darker than Uranus because of the higher concentration of methane and possibly unknown atmospheric chemicals. It is a world of motion and chaos, with the strongest winds in the entire solar system reaching speeds over 2,000 kilometers per hour. Neptune's storms are massive spinning tempests that appear and fade within days. One of them, the Great Dark Spot, was once as large as Earth and vanished mysteriously, only to be replaced by another. Its atmosphere is layered with icy clouds made of methane, crystals glowing faintly under the distant sunlight. Far below the clouds lies a dense, hot interior made of water, ammonia, and rock. Despite the freezing temperatures at its surface, Neptune radiates more heat than it receives from the Sun, hinting that it still holds energy from its ancient formation. This planet stands as a symbol of endurance, at the edge of our solar system where sunlight is weak, but discovery still shines strong. The Jovian planets are not alone. They are surrounded by entire miniature solar systems of their own. Each giant world has moons that range from tiny icy fragments to massive worlds that could almost be planets themselves. Jupiter has more than 90 known moons, including Ganymede, which is larger than Mercury and has its own magnetic field. Europa holds a global ocean beneath its frozen crust that may hide conditions for life. Saturn is home to Titan, a world with lakes of liquid methane and ethane and a thick orange atmosphere. Unlike any other moon, it feels like an alien Earth, frozen in time. Uranus and Neptune also have their own families of moons, each shaped by unique histories. Miranda, with its twisted, broken surface, looks like a shattered puzzle, pieced together by gravity, and Triton, Neptune's largest moon, orbits backward, hinting that it was once a captured object from the Kuiper Belt. Around each of these giants float rings made of ice dust and rock. Saturn's rings are the brightest and most extensive, but Jupiter, Uranus, and Neptune also have faint rings that shimmer quietly in the dark. Together, these moons and rings transform the Jovian planets into complete systems, worlds within worlds, each one telling a different story about creation and change. The Jovian planets are not just massive spheres of gas, they are living laboratories of physics, chemistry, and motion. Each one radiates more energy than it receives from the Sun. Especially Jupiter and Saturn, whose internal heat drives endless storms and swirling jet streams. Deep within their atmospheres, hydrogen is crushed into exotic forms that scientists call metallic. Hydrogen, a substance that behaves like a liquid metal conducting electricity and generating magnetic fields billions of times stronger than Earth's. These magnetic fields trap particles and create powerful auroras glowing like electric curtains over their poles. Neptune, despite being farthest from the Sun, has some of the strongest winds in the solar system, reaching speeds of over 1,500 miles per hour. Uranus tilts on its side, spinning almost like a rolling ball through space, giving it seasons that last more than 20 years. Each Jovian planet defies expectations, challenging scientists to rethink what a planet can be. They are engines of storms, heat, and magnetism, reminders that even in the cold darkness of the outer solar system, energy and motion never stop. Billions of years ago, when our solar system was still a swirling cloud of gas and dust, the seeds of the Jovian planets began to take shape. In the outer regions of that young solar nebula, the sunlight was weaker and temperatures were lower, allowing ice and gas to condense. Together with bits of rock, these materials clumped into massive cores far larger than anything in the inner solar system. Once these rocky and icy cores reached about 10 times the mass of Earth, their gravity became strong enough to capture vast envelopes of hydrogen and helium from the surrounding nebula. This process created the immense worlds we now know as Jupiter, Saturn, Uranus, and Neptune. The first two captured the most gas, forming the true giants, while Uranus and Neptune formed later and farther away, gathering more ice and less hydrogen. Today, scientists believe that studying how these planets formed can help us understand not only our own solar system, but also the thousands of exoplanets discovered around distant stars. Their origins are written in the clouds and magnetic fields of these giants, silent witnesses to the birth of our cosmic neighborhood. Each Jovian planet is surrounded by a family of moons and rings that form miniature solar systems of their own. Jupiter holds the largest collection with more than 90 known moons, including the four great Galilean moons, Europa Ganymede and Callisto Io burns with volcanic fire, driven by Jupiter's immense gravity, while Europa hides a global ocean beneath its icy crust that may hold the potential for life. Ganymede, the largest moon in the solar system, even has its own magnetic field. Saturn's system is equally breathtaking, with its majestic rings made of billions of ice and rock particles, ranging from tiny grains to mountain-sized chunks. These rings stretch for hundreds of thousands of kilometers, yet are only a few dozen meters thick. Beyond Saturn, Uranus and Neptune also possess rings, though darker and fainter, hidden in the dim glow of the distant sun. Their moons tell stories of collisions, frozen seas, and ancient evolution. Together, the rings and moons of the Jovian planets reveal the beauty and complexity of motion in space and remind us that even far from the sun, the dance of creation continues. The atmospheres of the Jovian planets are among the most violent and beautiful regions in the solar system. Each planet has its own layers of clouds formed by different chemicals and temperatures. Jupiter's atmosphere is striped with powerful jet streams that race in opposite directions, creating its famous bands and storms, including the Great Red Spot, a gigantic storm that has raged for centuries. Saturn's clouds appear softer, but beneath their pastel hues lie powerful winds and electrical storms that flash with lightning thousands of times stronger than those on Earth. Uranus and Neptune, though smaller and colder, have dynamic weather. 2. Neptune in particular hosts the fastest winds in the solar system, with speeds that can tear through its atmosphere faster than the sound on Earth. Methane in their skies absorbs red light, giving both planets their distinct blue shades. These atmospheres are in constant motion, driven by heat escaping from their interiors and the distant touch of sunlight. What seems calm from afar is in fact a world of unending storms and shifting gases, a breathtaking balance between chaos and harmony. Deep beneath the swirling clouds of the Jovian planets lies the secret to their immense power. Each of these giants generates a magnetic field far stronger than anything found on Earth. Jupiter's magnetic field is the most powerful of all, stretching millions of kilometers into space and creating a vast magnetosphere that traps charged particles and produces dazzling auroras around its poles. Saturn, too, radiates a powerful magnetic field almost perfectly aligned with its axis, a mystery that still puzzles scientists. Uranus and Neptune have magnetic fields that are tilted and offset from their centers, twisting and shifting in strange ways as the planets rotate. These magnetic fields are born from motion within the planets themselves, where hydrogen under extreme pressure transforms into metallic form, conducting electricity like a vast internal dynamo. The energy radiated from these deep interiors escapes as heat, driving fierce winds and storms across their atmospheres. It is this hidden energy that keeps the Jovian planets alive, dynamic, and endlessly changing even in the freezing darkness of the outer solar system. Humanity's understanding of the Jovian planets has grown through decades of exploration driven by curiosity and the desire to uncover the unknown. The first glimpses came from telescopes on Earth, revealing their colors, rings, and moons, but spacecraft brought us closer than ever before. In 1973, Pioneer 10 became the first probe to fly past Jupiter, followed by the Voyagers, which journeyed past all four giants, showing worlds more complex than anyone imagined. Jupiter's storms, Saturn's icy rings, Uranus's tilted spin, and Neptune's deep blue mysteries were unveiled in stunning detail. The Galileo spacecraft later orbited Jupiter, sending back images of lightning in its clouds and evidence of an ocean beneath Europa's frozen surface. The Cassini mission explored Saturn and its moons for more than a decade, capturing the beauty of its rings and discovering water jets spraying from Enceladus, hinting at life's potential. Voyager 2 remains the only spacecraft to have visited Uranus and Neptune, revealing their magnetic chaos and icy winds. Each mission has deepened our sense of wonder, reminding us that exploration is not just about discovery, but about connection to the vastness of the cosmos. Among the endless storms and icy worlds of the Jovian system, scientists search for signs that life might exist, even in the most unlikely places. While the gas giants themselves cannot support life as we know it, some of their moons may hold the right ingredients for it. Europa, with its hidden subsurface ocean, is one of the most promising worlds in the solar system. Beneath its frozen shell lies liquid water warmed by tidal forces from Jupiter's immense gravity. Ganymede and Callisto may also hide buried oceans, while Saturn's moon Enceladus sprays geysers of salty water and organic molecules into space. These findings have reshaped the search for life beyond Earth, shifting attention from rocky planets to the mysterious moons of the gas giants. Future missions such as Europa Clipper and Dragonfly aim to explore these worlds in greater detail, searching for chemical clues and energy sources that could sustain microscopic organisms. Humanity stands at the edge of discovery, once again ready to explore the dark and frozen frontiers, where the line between science and imagination begins to blur. The Jovian planets are more than distant giants. They play a vital role in shaping the balance and safety of our solar system. Their massive gravity acts as a cosmic shield, protecting the inner planets from countless comets and asteroids that could otherwise collide with Earth. Jupiter, in particular, serves as a guardian, its strong gravitational pull capturing or deflecting debris that drifts inward from the outer regions. Without these giants, the history of Earth and life itself might have been very different. Beyond protection, the Jovian planets influence the orbits of other worlds, helping maintain the long-term stability of the solar system. They also hold clues to how planets form and evolve, since they preserved much of the original material from the solar system's birth. Studying them allows scientists to understand the conditions that gave rise to planets' moons and even the building blocks of life. The Jovian worlds remind us that everything in space is connected. Every storm, every orbit, every gravitational tug, part of a grand system that works together in harmony. The study of the Jovian planets has opened a gateway to understanding worlds beyond our own solar system. When astronomers began discovering exoplanets, orbiting distant stars, many of the first ones found were massive gas giants like Jupiter and Saturn, orbiting close to their suns. These discoveries were surprising because they challenged our understanding of how planetary systems form and evolve. Some of these distant worlds, called hot Jupiters, complete an orbit in just a few days, while others drift in wide frozen paths like Neptune. The behavior of these exoplanets helps scientists compare them with our own Jovian giants, revealing both the uniqueness and universality of planetary formation. The lessons learned from Jupiter-Saturn. Uranus and Neptune guide our exploration of these alien systems, showing how gas giants influence smaller worlds around them just as they do in our solar system. The legacy of the Jovian planets extends far beyond their orbits, shaping how we look for new worlds and how we imagine life among the stars. They are both teachers and time capsules, preserving the history of creation written in clouds, storms, and magnetic waves. Even after decades of exploration, the Jovian planets still guard countless secrets waiting to be uncovered. Scientists continue to question what lies deep within their cores, where pressures and temperatures reach extremes. Beyond imagination, no probe has ever pierced their thick clouds to reveal what truly exists at the heart of these giants. Does Jupiter have a solid core, or is it a swirling ocean of metallic hydrogen? Saturn's perfect magnetic alignment remains unexplained, while Uranus and Neptune challenge models with their strange magnetic tilts and unexpected heat patterns. The exact processes that create their intense winds and storms also remain a mystery, and new data from telescopes and spacecraft continue to rewrite what we thought we knew. Perhaps the most intriguing mysteries lie within their moons: the hidden oceans of Europa and Enceladus, the icy crust of Ganymede, and the dark secrets of Triton, Neptune's captured moon. Each discovery brings new questions, reminding us that science is a journey, not a destination. The Jovian planets continue to whisper through storms and magnetic fields, calling us to explore deeper, to listen closer, and to never stop seeking answers among the stars. For as long as humans have looked to the night sky, the Jovian planets have inspired wonder and imagination. Ancient astronomers saw them as wandering stars, glowing with mystery and power. But today we know them as colossal worlds that reveal the strength and beauty of nature itself. Through the lenses of telescopes and the eyes of spacecraft, we have turned those distant lights into living worlds filled with storms, moons, and magnetic seas. The Jovian planets remind us how small our world truly is, yet how far our curiosity can reach. They show that the universe is not empty, but alive with motion, color, and history. Each time a spacecraft crosses their path, humanity extends its own reach into the unknown. We learn not only about these giants but also about ourselves, our need to explore, to question, and to understand. The story of the Jovian planets is not just a chapter in science. It is a reflection of our endless pursuit of knowledge, our desire to connect with the cosmos, and our place in the grand design of creation. The giants watch over us from afar, eternal guardians of wonder and discovery. Thanks for watching.